Hey everyone, we're just going to do a little presentation on electrosurgery while we're getting ready in the room. So hopefully you can see this presentation. So it's actually something that doesn't really matter very much, and I say that at the outset because a lot of people, they just have the guy from Irby or Olympus come to their unit, program the thing in. That's the last they ever think about electrosurgical settings. And I think that was the case with me until I started doing more polypectomy. So I think that that's something you can do. And actually, there's some very interesting recent evidence from the Sydney group about, in a pig model, about different types of electrosurgical energy and the effect they have. And essentially, the effect is the same. And probably what comes out of that is that it's more about technique than it's about electrosurgical energy. But actually, you can get a much more interpretable hot snare resection plane if you know what you're doing with electrosurgical energy. And that is important in terms of preventing recurrence, treating bleeding, et cetera, et cetera. And the final thing that you can have, as John was talking about earlier, and hopefully we can explain a little bit of that here, is that you certainly also with pedunculated polyps need to know what you're doing. So what is electrosurgery? One is coagulation. And so the temperature rises and these cells then dehydrate and shrink. And there's cut, and that's rapid heating so that the cell just burst and they're not shrinking and dehydrating. The proportion of cells coagulated to those that are cut can be varied depending upon the type of current that you're using, and this is what results in blended or mixed effects. And the resistance depends on the degree of vascularization and water content of the tissue. And this is a very important thing in polypectomy. So high water content is different to low water content, fibrosis and scarring. And so fibrosis and scarring don't conduct electrosurgery very well, whereas the bowel wall does conduct electricity very well. And that's important because other things that don't conduct electrosurgical energy very well are fat, for example. And a lot of people have trouble with resection around the ileocecal valve because they think, well, my God, I've stood on the pedal 4 or 5 times and somebody's still not cutting. And the reason is because fat does not, or it offers significant resistance to electrosurgical energy. Everybody knows that if you touch the plug, or maybe you learned it as a child, that you get an electric shock. And that's because it's the same thing. I mean, it's all electromagnetic energy, but the frequency of household appliances is down at 60 hertz, whereas electrosurgical energy is around the 300 to 500 mark. So you will not get an electric shock from electrosurgical energy, you will get a burn. So definitely it's another good thing not to have a connected device anywhere near your hand when someone's foot or someone might fall over onto the pedal, et cetera, right? So you get the idea. Don't get a burn of the electrosurgical unit just because you are not taking care. So more coagulation is required. One very important thing that comes from this is that if you have a snare, right, and let's say, for example, you wish to apply ligation to the loop of this polyp, so you ligate it at the base. That means you put a loop around it or a clip on it or something, and you get a very narrow point at the base from your ligation. And then you have a relatively open snare attached to the electrosurgery at the top. You may well actually, because it's monopolar and the current is passing through the patient's body, you may actually get burning and electrosurgical energy at the point of maximum constriction at the base, and this can be very dangerous for patients. So what about some practical recommendations? I think we're nearly there with the scope room. So practical recommendations flow from this. If you're doing monopolar snare polypectomy, so monopolar is the one with the patient having a plate, several factors affect the ability of the snare to resect. One is the voltage, so that's when you're turning up the setting. One is the current density, that depends how tightly the snare is closed on the tissue. One is the settings on the electrosurgical generator, the duty cycle, so that's the variant different types of coagulation cut currents. And the tissue impedance is very important, so that we've talked about a little bit already, but fibrosis doesn't cut as well, and nor does fat. And the surface area of the snare touching the tissue is also critically important, a little bit related to the tightness, the current density, and that are quite related, aren't they? So Do not use pure cut. If you're using pure cut, you're just going to have continuous bleeding. That's the first thing. So the settings that you want are some of the blended modes. You want a blended mode that you predominantly use for everything, like endocut is a good example. And then you want a mode which you turn to if you have bleeding. And normally in our practice, that is soft coagulation, because it's very, very good at coagulating. And it doesn't give a deep burn. In general, as we say here, a cutting current may lead to immediate bleeding. This is a very important point, and so let's do it again. Cut current causes immediate bleeding. Everyone thinks cut causes bleeding, but pure coag causes delayed bleeding. And that's what gets you out of bed at night, and that's what gets the patient out of bed at night. So absolutely, absolutely don't use it in its purest form. Highest current density, we've said that, is at the maximum point of constriction. Think about that when you're doing pedunculated polypectomy, as already said. And tissue resistance will increase as you start to cut. Now, submucosal injection has value in diminishing deep heating of underlying tissue. So do use submucosal injection. I'm not sure anyone's proven that, or I've not seen it being proved, but certainly this is for sure true that we see less injury because the submucosa is a potential space. After snare capture of tissue, tent the polyp away from the wall, and during EMR, close the snare tightly, however you do it. If you do it or the nurse does it, so that you let the current have its maximum point of density at the point of the snare. Hemostasis we'll skip for now because we'll talk about it later, and just be aware about your local guidelines for the use of pacemakers or defibrillators with electrosurgical energy, because it can be a problem and you don't want to jeopardize that. All right, I hope that was useful. I don't think does anyone in the room, there's some with me, and you have any questions? John, have you got any comments on that? I don't know if you're there. Otherwise, we move on to the live case, which